Hi friends, welcome to our channel. Our today's concept is angle of acceptance and numerical aperture of an optical fiber. Let's start the video. Before starting actual concept, let us understand some basics information about optical fibers. First one is, what are optical fibers? Optical fibers are essentially light guides used in optical communication as waveguides. They are transparent dielectrics and able to transfer visible and infrared rays over long distances. Now, coming to construction of optical fibers. Optical fiber is cylindrical in shape and it has three layers, namely core, cladding and polyurethane jacket as shown in figure. So here, core is the inner part of the optical fiber made up of plastic or glass and having refractive index which is always greater than the refractive index of cladding. And cladding is the outer part surrounding the core made up of plastic or glass. And finally, the cladding is enclosed by polyurethane jacket, which is the safeguard against unwanted reaction of the fiber with surroundings. This is the construction of optical fiber. Now next one is total internal reflection in an optical fiber. So in optical fiber, light will be transferred from one place to another place if and only if light in an optical fiber undergo total internal reflection. So for that, let us consider the figure which is displayed on the screen. Here, light source is in water. When angle of incidence of light is θ1, then ray will refracted by making an angle θ2 with the reference axis as shown in first case. When angle of incidence of light ray is θc, then ray will be refracted by making an angle of 90 degree with reference axis as shown in case 2. Then theta is called as critical angle. Now, when angle of incidence of light ray is θ1, then ray will be reflected by making an angle of θ2 with reference axis as shown in third case. So, when all the rays are reflected to the same medium, then the process is called total internal reflection, and it is possible only if angle of incidence is greater than the critical angle. So this is some basics about optical fibers. Now come to the actual concept, that is angle of acceptance and numerical aperture of optical fibers. For that, let us consider the diagram. In diagram, there is a cone-shaped structure AOA' called as acceptance cone. When incident ray enters the optical fibers within this cone, then only it undergoes total internal reflection. So from diagram, θ0 is the maximum angle made by the incident ray so that it will undergo total internal reflection. Then this maximum angle is called acceptance angle and sign of that angle is called numerical aperture. So numerical aperture gives the light gathering capacity of an optical fibers. Now let us derive the expression for angle of acceptance and numerical aperture. Again consider the diagram. Here consider a light ray AO incident at an angle of θ0 enters the fiber. Let θ1 be the angle of refraction for the ray OB in the diagram. The refracted ray OB incident at a critical angle of 90 minus θ1 at B and grazes the interface between core and cladding along BC. If the angle of incidence is greater than the critical angle, it undergoes total internal reflection. Let N0, N1 and N2 are the refractive indices of the medium, core and cladding respectively. Now, from Snell's law at the point of entry O, we get N0 into sin θ0 equals N1 into sin θ1. Therefore, sin θ0 equals N1 by N0 into sin θ1, which is also equals N1 by N0 into sin θ1 is also written as square root of 1 minus cos square θ1. Take it as equation 1. And also from Snell's law at the point B, we get N1 sin θc equals N2 sin 90 degree. That is, N1 into sin of θc is critical angle which equals 90 minus θ1 in the diagram. Therefore, N1 into sin of 90 minus θ1 equals N2 sin 90 degree. that is n into sin 90 minus theta 1 is cos theta. Therefore n1 into cos theta 1 equals n2. Therefore cos theta 1 equals n2 by n1. Take it as equation 2. Now substitute equation 2 in equation 1. Then we get sin theta naught equals n1 by n0 into square root of 1 minus cos theta 1 whole square, that is n2 by n1 whole square, which is equals to square root of n1 square minus n2 square whole divided by n0. So we know that if theta naught is the angle of acceptance, then numerical aperture is sin theta naught. Therefore numerical aperture NA equals sin theta naught, which equals 1 by n0 into square root of n1 square minus n2 square. If the fiber is in air, then n0, that is refractive index of air, is 1. Therefore numerical aperture becomes sin theta naught, which equals square root of n1 square minus n2 square. And angle of acceptance is theta naught, which equals sin inverse of square root of n1 square minus n2 square. This is the required expressions for angle of acceptance and numerical aperture of an optical fiber. In this video we have learnt about construction of an optical fiber, condition for total internal reflection, propagation of light through optical fibers, and also derived the expression for angle of acceptance and numerical aperture. If you like this video, then press the like button. If you got any benefit from this video, then share this video with your friends also. If you have any query regarding concept, then comment on the video. If you want more videos like this, then please subscribe to our channel. Thank you for watching.